Hey guys, today we're going to talk about something called the distance formula. So for the distance formula, we're going to start off by looking at this first slide, and this might help us be able to understand when we get to it. So the first slide, we have something that looks like this, and we are asked, what is the shortest distance from the home to the park? And we're going to use this in units. Every box represents 1 unit. So from the home to the park, we would say that's 1, 2, 3, 4, 5 units away. So the home to the park, home to park, would be 5 units. And then it says, what's the shortest distance from the park to the library? And the shortest distance would be 1, 2, 3, 4. So the park to the library, well, that was 4. We said this down here was 5. This over here was 4. And our last one, and this is where we're going to need something useful, says, what's the shortest distance from the home to the library? That would be this right here. Notice that it's not as easy as just counting the boxes because we're going like diagonally across. So what we can use to find this distance, though, is the Pythagorean theorem, because this is a right angle here. So if we do Pythagorean theorem, it would be 4 squared plus 5 squared equals, we'll call it x, equals x squared, which would be 16 plus 25, which would equal x squared. So we end up with 41 is x squared. So x should be the square root of 41. And when you do the square root of 41, we'll round to the nearest tenth. We get 6.4. So from the home to the library here is 6.4. That's the shortest distance. This is going to be kind of how we derive or how we figure out what the distance formula is. Whenever you're working on the coordinate plane, if you're going horizontally, you can just count. If you're going vertically, you can count if you want to find the shortest distance. But if you're going diagonally, we're going to have to use Pythagorean theorem. So let's look at our next little example that we have. On our second slide, it says, what is the distance from one point to the other? And our 2 points here, one of them's right here, and one of them's up there. So what's the distance represented by this line here from one point to the other? Now, in order to do this, when you have a coordinate plane, you can simply make a right triangle. So you can make the right triangle here. You just go over horizontal, and you keep going over until you're going to kind of collide with the vertical going down, and then you'll make the right angle there. And this makes a right triangle, and then all you have to do is count. We're 1, 2, 3, 4, 5, 6 units here, and we're 1, 2, 3, 4 units going up. So if we want to find the distance, we would do 4 squared plus 6 squared equals, in this case, d squared. 4 squared is 16, 6 squared is 36, so our d squared would be 16 plus 36 is 52. So d squared is 52, which means d is the square root of 52. And the square root of 52, when we round to the nearest tenth, we should get 7.2. So this distance here is 7.2. So really what we're doing is you're looking at, like, from one point to the other one, it's like how far do you change horizontally and how far do you change vertically. Because we want to figure out a way to do this without having a coordinate plane if we just have 2 points. So without having to plot the points, which is going to lead us to our next one. Our next question says, we'll find the distance between the points 5, -4, and -3, -2. We're going to find the distance between those points. Now, if we wanted to, we could go onto the coordinate plane here, and we could say 5, 1, 2, 3, 4, 5, -1, 2, 3, 4. This is 1 point, and -3, 1, 2, 3, -2. Right here is the other point. We could plot the points, and then we could say we're trying to find the distance between them. So we're trying to find this, the shortest distance from one to the other one, straight line. And then you can kind of make the right triangle. From this point, how far down do you go to get to the next point? You go down 2 units, and you go over 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Ooh, 1, 2, 3, 4, 5, 6, 7, 8. Sorry. So you go down 2 and over 8. That makes a right triangle. So you would have 2 squared plus 8 squared would equal, we'll call it d, equals d squared. So 4 plus 64 equals d squared, meaning d squared is 68. So d is the square root of 68. And the square root of 68 is 8.2. So d equals 8.2 for us. Now we want to try to figure out a way to do this without having to plot the points. Maybe we don't have coordinate planes. But we will write down that d is 8.2. And we really want to think of what we did here. In order to do this, we use Pythagorean theorem, and the 2 and the 8, those are the legs. Those come from like the vertical change and the horizontal change. So if we go back to our original points that we were given, 5, -3, and -4, -2, if we were to set up Pythagorean theorem, like we just had, a squared plus b squared equals c squared. In this case, c was d, so I'll make it d squared. That was our distance. Like I said before, one of the 2 legs was the horizontal distance, left and right. How far you're going left and right. And if you look at your x-coordinates, one of them is 5, one of them is -3. On the coordinate plane, one of them was 5 to the right, one of them is -3, so 3 to the left. So they're 8 units apart. That's why you'd have an 8 here. Or if you want to write it, you can even say it like this. If you want to find the distance between those 2, it would be, you subtract them. 5 minus -3 squared. And 5 minus -3 ends up being 8. For b, it's what's the distance in your y's. And over here, one of them was -2, so it went down 2. One of them is -4, so it goes down 4. So the distance between those 2 is only 2 units. One of them is 2 units lower than the other. And a way that you could do that here would just be saying like -4 minus -2. And then we're squaring it just like in Pythagorean theorem. And when you do -4 minus -2, that's like -4 plus 2, so you end up with -2. So you have -2 squared equals d squared. So 8 squared, again, you're going to get that 64. -2 squared, well, negative times a negative is a positive. And this is how you can do or finding the distance without using a coordinate plane to graph everything. Because then you end up with 68. And then from there we would have d equals the square root of 68, which we already found out was 8.2 when we round. So on the coordinate plane, if you want to find the distance between 2 points, you're really figuring out how far away are the x-coordinates, how far away are the y-coordinates, and then you're essentially using Pythagorean theorem. But there is a special formula for this, and it may look a little intimidating, but I'll explain in detail what it is. Our formula for this is the distance. I'm going to write it like this. Distance equals, we have a long square root here, and we have x sub 2 minus x sub 1 all squared, plus y sub 2 minus y sub 1 all squared. And that would mean, or that would be given 2 ordered pairs that look like this. So x coordinate, y coordinate, x coordinate, y coordinate, and we substitute in. You also could write it like this. This is the form that you're always going to see it in, but it's kind of the same thing as like this. The other one's one step ahead though. This might help us recognize the Pythagorean theorem more. This is like your hypotenuse, so the hypotenuse squared. One of your legs is the change in the x-coordinates, the other is the change in the y's. That's all these two are. They just look a little intimidating because we have a lot of letters and subscripts there. But all this is saying is what's the change in the x-coordinates. So this is like your horizontal change. Your x-coordinates. And this would be your y's. This is your vertical change. or your vertical difference between the two. So how far is one higher than the other one? And these are like the legs. Whenever you have the coordinate plane, you have any 2 points. We'll just make 2 random points. The y's are going to be how far up, that's one of your legs, and the x's are going to be like how far left to right you have to go, because they'll always make a nice right triangle, and then you can find that distance from one to the other, which would be right here. That's the D. So we're going to try to do some of these without graphing on the coordinate plane, just algebraically substituting in. So let's go ahead and look at our next example. It says, what is the distance between the points 5, -3 and 9, 1? So these are your 2 points. We want to find the distance between them. So our distance formula is the distance equals the square root of, and I'm going to rewrite it. We don't have to rewrite it every time, but it looks like this. So what you're going to do, your distance is going to be, you're going to substitute in. You can start at either one. I'm going to start here, call this 2, call this 1. So we're going to do x sub 2 minus x sub 1. So the x, remember it's always x comma y. So the x sub 2 is 9, x sub 1 is 5. So x sub 2 is 9 minus 5 squared. And really what we're doing is saying how far apart are the x coordinates. And they're 4 units apart. So 9 minus 5, that's where the 4 that's where 4 is going to come from. Then your y, we have x sub 2, which is 1, minus -3. So minus -3 and all squared. And this is saying how far apart are the y coordinates. So when we evaluate 9 minus 5, well, the x coordinates are 4 units apart. So 4 squared. And the y coordinates, well, they're 4 units apart as well. 1 minus -3 is 4. If you're on a number line here, or on the coordinate plane, you're going to be 4 units apart vertically. So that means our D is 4 squared is 16 plus 4 squared is 16. So our distance is the square root of 32. And then all we have to do is substitute in. So find the square root of 32. So our distance here is going to be 5 and when we round 7, we don't have any units, so we'll just write units. So the distance between these 2 points is 5.7 units apart on the coordinate plane. And this is how we can do it without having to graph the points and make that right triangle, because this 4 and this 4, that would be your 2 legs of the right triangle. So there's one more we'll try, then you can try some of these on your own. So our last one, it says, what is the distance between the points -3, 4 and 1, 3? And our distance formula is we're going to take the x coordinates and find the difference between them, square them, and then we're going to take the y coordinates, find the difference between them and square that, and that'll give us the distance here. So I'll call this x sub 2, y sub 2, this x sub 1, y sub 1. Remember, it's always x comma y. So let's substitute in. 1 minus -3, that's going to go in for our x's. 1 minus -3, and we're going to square that. And then 3 minus 4. 3 minus 4, I'm going to square that. So we are 4 units apart over here, so it's going to be 4 squared. Then over here, 3 minus 4 is -1, and we're going to square it, so it's going to end up being positive. Whether you end up with a negative in here or a positive, you're always going to square it, which is going to change its sign to be positive. So you should always end up, after you square, at this step, to have positive numbers. 4 squared is 16, -1 squared is +1. So the distance is the square root of 16 plus 1, which is 17. So the square root of 17 here. And again, this 4 came from how far away are these 2 points? They're 4 units apart. And the -1 was how far away are these? So they're 1 unit apart, but since we had this as our x sub 2, it ends up being a -1. And like I said, it's going to end up becoming positive because you're going to square it anyway. So our distance is the square root of 17. And when you do that, you should end up with distance equals, or round to the nearest tenth. And you get 4.123, which rounds to 4.1 units. So this is how we can use the distance formula. This distance is the distance between these 2 points. And this is how you can use it without making that right triangle on the coordinate plane. Just substitute in, just gotta know what the formula is and what all the parts really are. So go ahead and try some of these on your own. Have a nice day, guys.